Good morning, good evening, good afternoon. Welcome to the AI show. I am Cassie Brevu, and today we have a lot of really cool content to go over. A lot of cool things to learn about. If you were here last week, you learned about vector databases with us and Liam, and now we have more cool ways that you can use that. So the first one that we're going to be looking at, so we actually have two segments today, two separate AI shows. The first one is about how to use that cognitive search with OpenAI and function calling. Super cool. And then the second one will be all about images and how we can use vector search with images. So in the chat, tell me where you're joining from. We like to see and hear from everybody. And because we have two shows, I'm just going to jump right into it to make sure we can learn all this cool stuff. And then also be sure to hang out to get your questions answered, as both speakers will be here to answer questions live. Hey everyone, you're not going to want to miss this episode of the AI Show, where we are going to be talking about combining the power of vector search with function calling in Azure OpenAI service. Let's jump in. Today, we are joined by Derek. Welcome, Derek. Thank you so much for hanging out with us today. Why don't you tell us a little bit about yourself and what you do?
Yeah, thanks for having me on the show, Cassie. So my name is Derek Legenzoff. I'm one of the product managers on the Azure OpenAI service.
Awesome. And today you're going to be going over some really cool things with function calling from the Azure OpenAI service. For people that aren't familiar with what that is, can you tell us a little bit about it?
Sure. So what function calling really does is it enables you to use these new versions of GPT-3.5 Turbo and GPT-4 and be able to create structured outputs. And what that really enables you to do is be able to connect these models with other kind of tools or systems you have. So for example, you might want to connect to your search index, like we'll be showing you late in this video, to be able to retrieve data and augment your prompts. So you can leverage that in the prompt to be able to get those answers. Or you can also use it to add additional capabilities to the model. So for example, these language models really aren't that great at math, but now you can create a function that maybe is a calculator or does calculations that are important for your use case. So it really can help kind of augment the capabilities of these models and for scenarios that might have been difficult with just these models on their own.
Awesome. So we're going to learn how to do that then, right? You're going to show us how we're able to augment the model to better serve different scenarios that we need and make it better at things that maybe out of the box it's not great at.
Exactly. So we're kind of building off of the AI show that Liam did last week, where he created an index using vector search. So now what I'm going to show you how to do is actually use function calling to be able to query that index. And we'll actually kind of throughout this video kind of be building a little chatbot to help you search for recipes and find a good recipe to make. And we'd actually even leverage the capability of the model to help maybe tailor that recipe or come up with replacement ideas. So hopefully we'll be able to show kind of a nice little end-to-end scenario of how you can use function calling for a real-world scenario.
That's awesome. Let's take a look at how we can do that.
Sure. So I have a Jupyter notebook here set up, and up here I'm just importing some libraries and defining my credentials for both my Azure Cognitive Search Index as well as my Azure OpenAI service. And then next, what we want to do is actually kind of define the messages we want to send to the model, as well as the functions. And if we look at this function, there's a few key things we're going to provide. So we're going to you give this function a name. So in this case, we want to be able to query recipes from our Azure Cognitive Search Index. So we've named the function that. We're just going to give the model a few details about what this function is designed to do. So we're pretty simply just saying it's going to retrieve recipes from an Azure Cognitive Search Index. And actually, this description will actually be added to the kind of the prompt behind the scenes. So this is almost like a new style of prompt engineering, where within this function, we're giving details and teaching the model how to use our function. Because these new versions of GPT-3.5 Turbo and GPT-4, the 0613 versions to be precise, have been fine-tuned to learn how to use these functions. And then within the call, we're actually going to teach it to use our particular function. We're also going to give it the parameters. So in this case, I've defined a pretty simple function. It just has one property. It's a query. That's a string. And we're going to describe that it's the query string to search for recipes. So then I've also defined my user message. In this case, I'm just a simple prompt saying, help me find a good lasagna recipe. And now what I can do is I can send both those messages and the function to the model. and the model is actually going to determine if we should make a call to this function or not. And if it does determine we should make that call, then it's going to actually give us the JSON that it thinks we should use. So here we can see it's actually proposing that we call this query recipes function with the query term lasagna. And actually from there, the idea being that you would go and then what you do is you take the string, convert it to JSON, go and then actually call that function, get the results, and then send another request to the model.
And so the query string that's being returned is the query string that's going to be sent to our Azure Cognitive Search, right?
That's exactly right. In this case, now that Azure Cognitive Search has vector search, what we can actually do is you convert this query to an embedding and send that embedding as a query, so we can get even more accurate results.
So it's now helping us figure out what we want to ask our search index to get what we want returned, right?
That's exactly right. So
That's so cool.
essentially with function calling, you can define a variety of functions. So here we've just defined that one, but we can have a bunch of different functions. So what the model is really able to do is determine, based off the context of this conversation, if we should call a function, and then how we should call it. So you can really be able to do a lot with these capabilities. Oh, go ahead.
As the developer, do I still decide when it's called though? So it's suggesting that I call it, but I still control that the call is made, correct?
Exactly right. So with function calling, we're not giving the model actual access to these systems. All the model is ever going to do is kind of generate this query, and then from there, you as the developer can take this. You determine if you actually want to make that call. You validate this response and actually go and then make that call on the model's behalf and everything.
Very cool.
Cool. So this is a fairly simple example here, and let's imagine for a second that we're building a chatbot to help you find recipes and help you make something good for dinner. So we could also try like another example of maybe we're looking for a Mexican recipe that has beans and rice in it. So we can try that, and we can see now it's able to convert that to a query as well. But as another example, if I'm using this chatbot, I might just say something fairly simple like, what should I cook for dinner? And in this case, the model does a pretty good job based on the context of giving it. It's trying to query for dinner. But if I have a search index of recipes, this might not be a particularly useful query. So what I could actually do is do a little bit of additional prompt engineering and actually add a system message to give the model a little bit more context about what I'm trying to really do here. So let me just paste in the system message I prepared ahead of time. And so essentially now I'm just telling the model, hey, you're an assistant that's a large language model designed to help users find and create recipes. You have access to an Azure Cognitive Search Index with hundreds of recipes. And then the other thing is, like in the case of this dinner, I really want it to be interactive. If I say, hey, help me cook something good for dinner, I want it to kind of carry on that conversation and help me come up with ideas before it actually goes and issues that query. So now I'm telling it, hey, you're designed to be an interactive assistant. You can ask users clarifying questions, help them find the right recipe. So now after I add all of this in, when I go ahead and send this request, now it's going to determine, hey, I'm not ready to call this function yet. I need to get more details from the user. And now it responds, sure, I can help you with that. Could you please let me know if you have any specific preferences or dietary restrictions? And this is a fairly simple system message. You could always add more details to try to give it a little bit more personality and stuff like that. But you can see pretty immediately with just a few sentences, we're able to kind of completely change the behavior of the model.
I'm thinking to myself, and I think you've just automated half the conversations married couples have, but what should we have for dinner? So we can just let the OpenAI model help us figure that out and suggest something. And now we've saved ourselves a lot of time. I'm trying to figure out what we should have for dinner.
Yep, totally. I'd honestly love to use something like this by myself. When actually, one thing I find when I'm trying to cook is I might have like just a few, like maybe I have like broccoli and tofu around or something, and it's like I need to find a recipe that has those things. And so this function we've defined currently is fairly simple. It's really just we're just passing in a query, and actually within Azure OpenAI service, we now support Azure OpenAI on your data, which actually makes it really easy to do this retrieval augmented generation pretty much like out of the box. So what I wanted to show is actually how we could make this function a little bit more sophisticated, actually tailor it even more to our use case. So I've defined like a slightly more complex function. does a little bit more that we might want to do in this use case. For example, so we still have that query string, but now I have an ingredients filter where if I list ingredients like beans and rice in my recipe, I want to actually be able to explicitly add a filter. So in addition to this vector query that we're going to be sending, we can also add explicit filters in Azure Cognitive Search to kind of trim down the results. And one thing that's kind of interesting here is so Azure Cognitive Search has a specific syntax for being able to filter. So actually, within this, we need to teach the model how to create like appropriate filters for Azure Cognitive Search. So I need to teach it, what are the names of my fields? What does that syntax look like? And so in this case, in the ingredients filter, I say this is an OData a filter to apply to the ingredients field. Only actual ingredient names should be used in this, and then we give an example of what this filter should look like. And I also have another field like if you're me, a long work day, I usually just want something that I can cook in like 25 minutes or less. So I also added a time filter so that we can filter down based off of the the time the recipe would take. And actually, before I dig in any further, I should probably just show you kind of what an example recipe looks like in the search index. So you can kind of get a feel for it. So we'll have a category, recipe name, the full recipe itself, the description, and we have like that list of ingredients and that total time. So we're essentially using these two fields now to be able to filter down a little bit further.
And those are the static search things that are going to be sent in along with the vector.
That's exactly right. And actually, in just a second, I can show you kind of what the model will generate for these filters. So now I can try that same query I tried before of find an easy Mexican recipe with beans and rice, and it should hopefully be able to create those filters for us. Now we see the query is Mexican, so we're going to be able to search for all like Mexican type food. We have that ingredients filter. Oops. So it's going to filter down to only recipes that like explicitly mention beans and rice. And we've also added a time filter where it's going to look for recipes that the total time is less than 30 minutes. And actually, with that, I did bake in kind of a little bit of like business logic into this here too, where I explicitly told the model like if someone's asking for easy or quick, let's filter down the recipes that take less than 30 minutes. So we can really kind of add a lot of logic into this function call to make the model perform how you want it to.
Very cool. So we're really describing what we want in the JSON call so that it can make an accurate request.
Exactly. And so you get kind of the full flexibility to define this however you want. So you can do kind of prompt engineering within this function call, within your system message and all that stuff. So you can really tailor that behavior so you can find the most relevant results for the user and kind of give them that experience that they're looking for.
And from like a way that you would implement this in an application, you're setting all this up right now and we're testing it and we're kind of iterating through it. If I was going to be putting this in an application feature, would I be sending in this system message and function every time I start a session with the model?
Yeah, great question. So yeah, like normally when you're using these models with Azure OpenAI, you're going to include the system message in every request, and then you'll also kind of keep a running list of the user and assistant messages. So like in this case, I'm just showing you kind of that first message, and we're always just setting that one user message. But traditionally, what I'll show you kind of towards the end is we can kind of continue on the conversation and add the previous messages into this array. And actually, what I've showed you so far is really just showing you kind of how you can be able to create you get the function call from the model. But I think what I'd love to show you next is how we can actually go and kind of string all of this logic together and actually kind of then be able to retrieve the recipes from the search index and then you get those results.
Yeah.
So I've defined this function called generate embeddings. This is a fairly simple function. You're just going to pass in a string, and then we'll get the embedding back. And so we're going to use that. So every time we send a query to the search index, we'll first use Azure OpenAI service to get that embedding. That we're able to do that vector search in Azure Cognitive Search. And then I've also defined a fairly simple function for calling Azure Cognitive Search. I'll pass in that query and pass in my filter. So I have a little bit of logic here just to join the filters together properly. And then now I'm using all the bells and whistles in Azure Cognitive Search. So I'm using vector search here, like you're mentioning earlier. I'm also using hybrid search because I'm still sending in that the raw string. Like in this case, the string was like Mexican, and that way you kind of keyword results and the semantic results. And like I think the one example I love to give there is like if you search like ice cream, vector search is really good because it's going to be able to get you results on like ice cream, frozen yogurt, gelato. But if you only got results on frozen yogurt and gelato, you'd probably be a little bit upset. You want to see some ice cream results too. So I think hybrid is really good because it takes advantage of um, those keywords as well. And then we're also leveraging semantic search, which I know Liam talked about in his video. So we're kind of leveraging all the bells and whistles of Azure Cognitive Search here.
Awesome.
Um, and then and then so the last thing I do is so the model is going to return so Azure Cognitive Search is going to return a bunch of JSON. But what I really want to do is I want to kind of take the text from Azure Cognitive Search and put it in a format where the model is going to understand it well. So what I'm really doing is I'm looping through the results here, and then I'm going to kind of print out the recipe ID, the recipe name, and the description of that recipe. That's what we're going to kind of give back to the model, so it can use that to kind of inform its response to the user.
Where we're at so far is that you have uh, told the OpenAI model what you want it to assist with. It's giving us a JSON result with suggestions based on a prompt that we sent in. And then from there, we're parsing that out. And now we're going to query cognitive search to get back from our index recipes that would fit that. Correct?
That's exactly right.
And then are you going to take that and feed that back into the OpenAI model? Or is that just going to be displayed to the user, or what's next?
That's exactly right. Actually, so right below this, I kind of have the logic all to stitch it together. So now that I define that function. So I've defined the function in the prompt. So now I need to actually define like the function we want to call when that gets triggered. So we define that function to call Azure Cognitive Search. So now what we need to do is we need to stitch all this logic together. So I wrote this run conversation function. We'll send that that initial call to the model like we were doing up above. And then at this point, we're going to check if the model tells us to call a function or not. And then if it does tell us we need to call a function, then we're going to get the function name. Make sure that's a function that we actually are able to call. Then we'll go ahead and actually call that function and pass in the arguments. And just for demo purpose, when we run this, I'll print out like the function call. But then once we get the results from the function call and everything, what we'll do is we're going to append that back into this array of messages that we have, and then make another request to the model. And then that's how we're going to kind of get this final response from the model. So now that we've defined the function to call Azure Cognitive Search and this run conversation function to kind of go through that process, what we can do is I've defined the system message again, and now we have a new query. I want to make a pasta dish that takes less than 60 minutes to make. So let's go ahead and run this. We can kind of see the end-to-end flow here. So we can see we got the function call like we'd hope. It's querying. It wants to query for pasta and filter down to recipes that take less than 60 minutes. That looks perfect to me. And then we can see the results that we got from Azure Cognitive Search. We got pesto pasta and some other recipes. So now at this point, what we needed to do is kind of then you take this function call, take the output function call, and use that to send another request to the model. So you can see now we're about to send another request, and you can see kind of all the details that we now have in the prompt. And then when we send this, we're going to get this final response from the model, where it's going to kind of take this data we give it and kind of really give it to us in a nice, natural language way. So here are a few pasta dishes that take less than 60 minutes to make, gives us those options and everything. Well, and now that we have the basics working here, we can actually take a little bit further. Like one thing you might notice is it's not actually telling us how to cook these recipes yet. And if you had a UI, I'm sure you could just make these hyperlinks and kind of handle that in the application layer. But I figured might as well show how we can let the model be able to do this as well. So what we can do, we had this one additional query recipes function, and actually one thing to call out, in my testing, I found out the ingredients filter was actually a little bit too rigid. So like if we filtered down to beans and rice, a lot of times it might say like brown rice or white rice, and then my filters are a little bit too explicit for that. That's actually where vector search is super useful, where it's going to be able to do kind of like that semantic similarity and be able to find stuff. So I've actually kind of taken out that ingredients filter for now, and we're just going to leverage this time filter because that one did work really well for my scenario. And then I've defined a couple more functions as well. So one is a fairly simple function to go ahead and get the recipe. Is essentially we're going to take the recipe ID, which we gave to the model in the previous function call, and the model can use that to go and look up the full recipe. And another one, like I don't know about you, but I don't get to spend quite enough time cooking, so I'm not really good at like recipe like measurement conversions. So I thought it'd be nice just to have a function to kind of you give some new capabilities to the model where it's going to be able to convert these different measurements and everything. So if you don't have any like clean teaspoons around, you can figure out what the appropriate number of tablespoons is, stuff like that. This is another fairly simple function where we're going to pass in the amount and like the original unit and the unit we want to convert it to. So the same thing, I've defined these functions in code as well. Actually, Copilot Chat helped me create this one, which was super nice. And then we have this get recipe function that we pass an ID. We can see that we're able to get that full recipe back. So now we can try this one more time just to test out these new functions. So if I say you get details in recipe 124, and obviously a user wouldn't quite do that, but just to show that the function's working, we can see it's able to do that. Or if I were to ask it like to convert how many cups is 2 tablespoons of butter, we can see that it's able to generate that correct function call for us as well. So at this point, we've kind of gone through the whole development process of of getting this all wired up. Do you want to see the thing running end to end? See if we can help it find
Yes,
a dinner recipe for us.
absolutely.
Great. So I've stitched all this logic. I've kind of copied and pasted all this logic over into this run recipe chat function. So just go ahead and run that. And now we'll be able to give it kind of a few messages and kind of have that true conversation. Let's start with something simple. Help me find something good for dinner. To this point, we taught it that it should be prompting us to come up with some ideas. So now it's asking, do you have any cuisine or ingredients in mind? So how about this? How about some Thai food that I can cook in less than an hour? And just so you can see that you've gone ahead and kind of printed out, so it's searching for Thai, and total time is less than 60 minutes. And then we can see the recipes it came up with. So it's proposing your Thai peanut noodles, Thai cashew tofu stir fry, and so on. And then we can see kind of the response from the model. And maybe reading through this, the Thai peanut noodles sounds pretty good. So now we can say, show me the recipe for Thai peanut noodles. And we can see it now. It prints out that full recipe for us. We get the the name, description, details on like the prep time and everything, and the ingredients, and then those instructions. You see it's printing twice. Just one is the function output. The other one is the actual response from the model. But let's say now it's asking for rice noodles. I don't have any rice noodles on hand. So one nice thing is in addition to using these functions and be able to query Azure Cognitive Search to get our data, we can still leverage all the knowledge of the model to help us have this really useful assistant. So maybe I say, are there any good alternatives to rice noodles? And now it shouldn't be calling a function or anything. It's just going to actually leverage the knowledge of the model itself and give us some ideas of we could do soba noodles or udon noodles or zucchini noodles. So we're able to kind of combine both what's in our search index and what we've kind of groomed there, but also be able to combine the power of the model to really create a nice interactive chatbot to help us find exactly what we're looking for.
So we went over a really cool example of how you can leverage Azure OpenAI Service and Azure Cognitive Search to create a recipe assistant with really not that much code. Super cool to do. Where can people go recreate this and learn more?
Oh, well, so first, I'd recommend you can go check out the blog and documentation on vector search and Azure Cognitive Search to learn more about how to get up and running with that. In addition to that, you can check out the documentation on function calling and Azure OpenAI. Within that documentation, we'll link out to some sample code that will show you similar end-to-end patterns of how you can define some functions and then kind of get things running end-to-end to be able to really build out that experience that you're looking for.
That's great. So this is all stuff they can go do right now.
Exactly. All of this is publicly available. Both vector search and Azure Cognitive Search and function calling and Azure OpenAI are in public preview. So you can go ahead and start playing. And we're super excited to see what our customers build.
That's great. Thank you so much for hanging out with us today and showing us these neat features.
Thanks for having me on the show.
Okay, so we now have Derek here to hang out, ask and answer questions. And there's been some activity and great questions here. I like this one where he's just like mind blown because it really is so cool what you can do with these tools.
It's definitely exciting how easy you can make it just to wire these things up together. It's fun, just all these different problems you'll be able to solve.
Yeah, and I thought that was a nice kind of segue into what are your thoughts on the possibilities of these models and these tools that are coming out using OpenAI function calling, adding in cognitive search? What are your thoughts on those?
Oh man, I mean, there's just like so much possibility. It's one of those things like, I find the space moves so quickly. Like often we release these capabilities and we tend to even just kind of learn together with our customers what's possible, like kind of our creativity combined with them. So I think we've showed you some kind of common patterns of you'll be able to reach out to data in your search index. But I think there's probably so many more functions people come up with. I'm sure there's even more you could do within kind of function calling for Azure Cognitive Search. Even like you could you add in scoring profiles to be able to sort the results in different ways, stuff like that. I'm sure we'll see folks write functions to be able to call out to other systems. I think one area I think is super interesting as well is just really even kind of expanding like beyond even just making calls to other systems, just giving it like access to perform simple calculations or doing stuff like that. I think could be really powerful. Or like you could even do stuff like have the model write code to create a visual and render that visual to a user. I think it's kind of an extensibility thing. So really anything customers want to do, I'd certainly recommend at least you're giving it a try and seeing if you can make it happen.
Yeah, there's so many possibilities. And I think that what's going to happen is people are going to start running into, their technical problems and realize, oh, hey, I can use OpenAI model, cognitive search, and I can create a much better solution than I could have without these tools. And so that's where I feel like we're just going to see just the amount and the power that we're going to be able to really do with this. So let's see, we have another question here. What would be the workflow to expand models context, discussion, awareness? So I think he's asking kind of like, how do we make the model understand more? I think is what that's question is.
Let's see. So in terms of expanding the model's context, so as you might be aware, these models tend to have some sort of token limit. So for example, like the original version of GPT-3.5 Turbo is limited to 4K. Now there's actually a 16K version of the model. As we're kind of having these conversations, we're generally kind of the typical pattern is you're just going to keep appending on to that conversation, but then eventually you need to start truncating messages or do something like that. I would particularly like there's kind of a balance between like how much conversation history you leave on versus the cost, because you could set it in your application to always like check the tokens and use up to the 16K tokens, but then that's going to be pretty expensive compared to if you limit it to 8K tokens, because you're going to have all that extra conversation history. So that's part of it. Is one is kind of managing that conversation history, and one pattern we see here is the idea of memory as well. So another thing you use Azure Cognitive Search for is if there's particularly kind of important messages in a conversation, you can either give the user the ability to kind of save that information somewhere or like have some sort of automated process. Then you could actually have Azure Cognitive Search go and retrieve like previous messages and kind of stick those in the conversation history. So it can be kind of even more aware. I believe Semantic Kernel has some patterns that like some samples out there showing how to actually build that in. Or I think another interesting possibility with Azure Cognitive Search, you might, let's say you have like a PDF that's like 1,000 pages. You can't just stick all of that in a prompt. But what you could do is you could kind of chunk your content before you stick into Azure Cognitive Search, and then that can be kind of retrieve like the most relevant part of the document. Or Azure Cognitive Search also supports like semantic caption, so they have a model to actually go and retrieve like the most relevant part of that document when it shows up as a search result. So that could also help you be able to get more out of your context because you're just putting the most relevant part of the document in the prompt. So lots of different options there, definitely.
Yeah, and I think you're kind of getting into the prompt engineering and some of the different things that's really great about cognitive search, because you're limited by tokens, but you want to be able to get the best awareness and understanding of the model, doing different smart things to be able to send in the right information to get the best result, and then having that change as you go is kind of part of the new development process with these models. It's super interesting. All right, I think that's all the time we have for questions. But feel free to keep putting them in the chat. But we need to move on to our next segment. So Derek, thank you so much for hanging out. And this was such a cool demo. I think the possibilities are endless and I'm really excited.
Yeah, thanks for having me on.
So then now we are going to be looking at how we can use image search with Azure Cognitive Search. So we were looking at text ways and different ways that we're creating text to vectors and doing vector search. You can do that with images too. So let's learn more about that.
Hey everyone, you're not going to want to miss this episode of the AI Show where we're going to learn how you can revolutionize image search with cognitive vector search. Let's jump in. Today we are joined by Varsha. Welcome. Why don't you tell us a little bit about who you are and what you do?
Thanks, Cassie. Hey everyone, I'm Varsha Pratsarthi, product manager on Azure AI, and I focus on computer vision technologies. I'm happy to be here, excited to share more about image retrieval using vector search.
Cool. So we did a show recently showing how to use cognitive search for vectors and focused on text. But this time we're going to be looking at images. So can you tell us a little bit more about how image search works within cognitive search?
Yeah, so image search or image retrieval systems have traditionally used features like tags, labels. These are extracted from images or even descriptions to compare images and rank them by similarity. So, keyword search is the most basic form of this information retrieval approach, where the search engine looks for the exact match of a keyword entered by the user and returns images that contain the exact sort of keyword stored as content labels or image tags. And keyword search, as you can imagine, relies heavily on users' ability to input specific search terms. So let's take an example. I love hiking. I'm in Pacific Northwest. I'm trying to find images of like hiking with friends in the rain, right? Again, hiking as a word or term is not used globally, right? It could be bushwalking in like places like Australia or trekking in places like Asia. So if the images aren't tagged with hiking specifically, you wouldn't be able to find those images. Um, Now, contrast that with vector search, right? On the other hand, where you have semantic similarities between the user search or the context within the search query, and that is being compared with contents present in the image. So even if you search for something like trekking or hiking or bushwalking, all of those search queries would lead you to the same sort of images that you're looking for that are relevant to the search query. So in this case, for vector search, both image and text is converted into vectors and stored in the same high dimensional vector space. I'll show you a demo in a minute and how Florence enables the vector search within images. It enables both text to image as well as image to image vector search.
Okay, cool. So that really tells me a lot about how it can kind of enhance maybe some of the like current features I might have to solve, searching for keywords within images. Now I'm going to be able to get a much better response because I'm going to be able to have a more semantically correct search using, you said, the Florence model. Can you tell me more about what the Florence model is?
Yes, great question. So, as we know, by now, like with ChatGPT, DALI, BERT, the industry is definitely moving towards large foundation model, and Microsoft has also invested and trained a large foundation model for vision and language specific tasks. The code name being Project Florence. It's a transformer-based model trained on massive amounts of data, billions of text-image pairs using self-supervision. Now, why is Florence important, right? So traditionally, to train a computer vision model, you'd collect a relevant training data set, label it for specific tasks. So if you're training for object detection or tag classification, you train a model, label the data for that specific task. And for each task, you train an independent model. And whereas for foundation model, which is Florence, you train one base model using massive amounts of data. And in this case, we're using both image and text. So it's a multimodal base model. And then you have adaptation models that help you fine tune this base model for individual tasks like classification, tagging, image captioning, and so on. It also does enable newer tasks like image retrieval or visual questioning and answering, like visual chat. So it's a multimodal base model that enables all of these new user experiences and scenarios.
Okay, so I understand now what the Florence model is and the power and capabilities that it's bringing to this task. Where can people learn more about the Florence model?
So we released Florence earlier this year. So there are research papers published, and you can find out more through that, understand more about how the model was trained, how the model performs on benchmarks. So you can find out more with those published papers.
And then let's see how this works. Can you show me how this works within the cognitive search functionality?
So let me start with Vision Studio experience. This is a no-code interactive experience where people can try out all the Vision features that are available within Vision AI. So I'm specifically going into searching photos with image retrieval. So here you can put in a natural language sentence as a form of text query and find images that you're looking for within your data set. So before I jump into the demo, I do want to make it clear that these sample images don't have any metadata associated with it, so no content labels or tags associated with them. And we've provided a couple of these image data sets that people can try and test the Florence vector search experience with. So let me quickly go through maybe one or two of these examples. So I'm picking manufacturing in this case. So these are the images that you see below are the images present in the data set. There are about 250 of these images. Now let's go search for a query. So I'm picking one of the pre-curated ones. So let's take a look at boxes on a conveyor belt, for example. So you see images that pop up. Again, none of these images have any metadata associated with it, so it's just pure vector search. And you can see more images as you go through the slider. This is all the images that are relevant to the query that I've typed in here. Now let's try another one, people looking at tablets together. Again, you see these images that are popping up. Again, I can increase and see more of these relevant images pop up. You could also try your own custom query. So, and I can change this to people looking at information on a tablet together, wearing maybe safety hats. Let's try that. Now you're seeing images with people wearing safety hats looking at the information together on their tablets. Now, as you can imagine, these are complex queries that we're looking at, and Florence does a great job with vectorization and finding the relevant images in this case.
So what's happening here is we have these data sets and the Florence models running and giving the results based on the text prompt that you're giving it. And then that's how it's able to get these. There's no metadata, there's no text associated with it. It's all with the power of Florence.
Exactly.
Very cool.
So let me go to a concept page. This is a publicly available page within Azure Cognitive Services. So let me just go through what's happening with the Vision Studio, right? So we saw a bunch of photos within the photo dataset or the photo library. You vectorize those images using Vectorize Image API. Same thing with vectorized text. You take the user query, which is in the text form, vectorize that. Now that you have vectors in the same space, multidimensional space, you store it in a vector database. And then you perform something called a similarity function. And here I'm using a cosine similarity, but you could essentially use any distance function to measure the similarity between the two vectors and find the top n or the top 10, 5, whatever the image vectors that you're looking for, and map these vectors back to the images and provide that as results. So that's essentially the concept of how the image retrieval system with vector search works. I do want to go back real quick on the studio aspect. So we just saw the curated data sets and sample data sets with the text query. You could also try with your own images signing into Azure account. You can bring in 500 images, quickly create a POC and see how Florence works with your data set. With that, this does limit, the demo is limited to 500 images. So if you want to create your own API dataset, I would highly recommend to get started with Cognitive Search, which makes it easy to set up a vector database, create a search index, and have that end-to-end search system set up.
That's so cool. I think showing how it worked is really helpful because it seems very magical when you just see it work, right? But then when you break down step by steps how we're taking images and words and putting them into vector space, and just if they're closer together, they're more similar using the cosine similarity. And that's how you find it. I feel like every time I see that, it still is just so brilliant and simple at the same time. And it really kind of puts together how they're able to work so well.
Yeah, exactly. So now let's jump into how vector search works with cognitive search, specifically for images. So you might have seen in the previous session that Liam shared, we're using the same data set and sharing the same index. So in this case, it's a recipe of a food and ingredients present in those foods. So text is associated with it. But in this particular demo, I'm only using the images within the document set. So it's only images of food and like recipes associated with it. With that, I'll get started with what I'm trying to do on this Python notebook. So I'm importing the libraries that I need to set the demo up. I'm also importing the index from Azure, Cognitive Search, the search index that was already set up. I have a JSON configuration with all the passwords and service endpoints. Here, in this case, you would need two accounts, one for Azure Cognitive Search and one for Azure Computer Vision. Both of these accounts have been set up, so I'm just creating those connection and endpoints. So let me run that.
And what is the computer vision service used for? Is that part, you need to use that as part of the cognitive search, or how are those two working together?
Yeah, great question. So cognitive search today allows you to bring in vectors, whether it's like OpenAI vectors through Ada embeddings or Florence vectors through Vision embeddings. For all of these services, you would have to first figure out where to generate these vectors before bringing it to cognitive search. So for images, we're using Azure Computer Vision APIs to generate those vectors for images.
Okay, makes sense.
Awesome. So here I'm defining two functions that we just spoke about, generating embeddings for images for the image set. And here I have around 2,300 images of food and sort of the recipe data set. I'm using the image retrieval API, in this case, vectorize image API, to generate vectors for the image data set. Doing the same for text and the text query using the same version, which is another key point. Different versions of the model does have slight variations in the way vectors are presented, and we do not recommend different versions to be used together.
So you want to make sure that you're using that same model also when you create your index and vectorize your images. So you want to, okay.
Yeah. So a vector that is, or the model that you're using for vectorizing text and vectorizing images need to be the same model in the same vector space, which is where you can do the right comparison and find out the semantically sort of similar images for that text query.
Makes sense.
Awesome. So moving on, I'm just running this code to vectorize images and text. So that runs successfully. Now for the fun part. So here I'm going to show both text to image search as well as image to image search. So let's try something like fish tacos. I'm taking the top 5 images and you'll see the results at the bottom. So you're seeing both scores. So I'm displaying the score here and the image ID. And again, image ID is important for us to give the image back and sort of map it to the relevant document this particular image is present in.
So we, just to kind of go over the call that was made. So this is the Python API or SDK, and we're calling the search client. So we have the fish taco text, and we are sending that in. We're generating the vector for that text, and then we're sending it into the index that we've already created, and then it's going to return the image that is most similar.
Exactly.
Okay.
Exactly. So, so fish tacos, again, an easy one, and you can also see the score of the distance function. So these are Florence similarity scores that we're seeing here. So let me just scroll down. So these are relevant images that we're seeing with fish tacos. They all look great. So let's try something a little more complicated. So garlic shrimp with green onion, right? Let's see what that would generate. Let's try something else. Maybe ramen with boiled eggs on the side, which is my standard order. Let's see if that works.
Every time we do this data set, it makes me hungry. Like I just had lunch, still hungry now. Ooh, that looks amazing.
Right. So clearly it's doing a great job with image search. And you could also type in something with like, I don't know, let's try that. Florence also does a good job of just like figuring out what the user is asking for. Like again, the term doesn't need to be specific, doesn't need to be correct with respect to the spelling errors. And as you can see, it's giving me results for shrimp pasta or spaghetti pasta with shrimp.
So, what type of use cases are you seeing customers or people interested in using these features for?
Yeah, definitely a lot in digital asset management. So there's a huge need to be able to reuse the assets that were created by either marketing agencies or by like people licensing data. Again, there's a huge cost nowadays to have like data licensing done. So you want to be able to utilize whatever data that you're buying or licensing to the utmost capability. So discovery and search and like aspect of being able to find what you're looking for as instantly as possible are all features that we're seeing where our customers are using it for. The other neat thing that we're also seeing people use it for is more like product recommendation or product cataloging, where they're not only using image search as like the primary pure vector search, but also augmenting it with metadata around it. So you can think of like PCs having different versions of like different OSs or laptops with specific product IDs, or it could even be clothes with specific product IDs. So you're augmenting the vector search with metadata search, and we call that hybrid search within the cognitive vector search pipeline. So you could do something like that as well, where you could have flexibility of doing both.
That's so cool. I could see it on the similarity search. Like, I want something that looks like this. Or maybe I'm on like a food ordering app and taking pictures of
Yeah.
my food finally makes sense because I find a meal that I had and I want to order something like
Yeah.
that. I mean, that'd be kind of interesting too, just the different ways that you could use images that you have in order to find something similar.
Exactly. Like I look at a ton of Pinterest boards and I'm like, okay, where do I find this piece of clothing? Doesn't exist today, but
Sure.
you could soon have that as an image input to one of these websites and get like the product that you're looking for.
That's so cool.
Awesome. So let's jump into, so we saw text to vector. Now let's check out image to image vector search. So here I'm pulling in a picture of lasagna. So let's try what it returns.
So now we're taking an image instead of text, embedding that and sending that as the query.
Exactly. So we're looking at this is the picture that I'm using to send it to the query for vector search. And here are the results that I'm getting back. Again, with pretty high confidence. Again, possibilities with image to image search are endless. We've seen even within like chat experiences or bot experiences, people send like products looking for like similar products that they're looking for if something is out of stock, or if they have a very specific like snapshot that they've taken, don't remember where it is from or what brand it is of, they could just easily search with the image and find relevant links for those products.
So, what different languages does this support? I see we've been using English. What other languages can we vectorize?
Yeah, it's a great question again. So right now we support English with the embeddings, but we do have a multilingual model that supports more than 100 different languages,
Oh,
and
wow.
that's coming out soon. So stay tuned for that.
Okay, so that's not out yet, but it's coming.
Yes.
Awesome. And then the other question I have is I see that we're using Python and we're using the Cognitive Search SDK. What other languages are supported for this, programming languages?
Yeah. So currently, the computer vision API is endpoints, REST endpoints that you could use. SDK in Python, C++, C Sharp. Those are all coming, so should be available in a few months. As well as on cognitive search, you already have SDKs available in popular languages like Python and C++.
Great. And then you're using Azure data sources. Does my data need to be in Azure, or what different data sources are supported?
Great question again. So it doesn't need to be in Azure. Definitely, it helps within cognitive search to have Azure data or Azure blob storage. But you can also bring in your storage, whether it's local or storage that is in other services, and plug it into Azure Cognitive Search.
Great. So you have the flexibility to plug in your data source and have it indexed.
Exactly.
Um, Another question I have around indexing your own data is I know there's tooling within it. We kind of talked about that on the last episode, so everyone should go check that out for getting those indexes set up. How frequently should someone be re-indexing their data? Is that kind of by a basis of what they're trying to do, how often their data changes, or how do people make that decision about when they need to create the new index that will overwrite the existing one?
A great question again. So again, if the data set hasn't changed, if you're dealing with like the same 5,000 images, you don't need to reindex ever, unless you want to switch over to a different model or you're trying something else that is not available in the current indexed model. But as you bring in more images or more text, you would have to do an update to the index. So it wouldn't be re-indexing for all of the images, but just for the new images to update. And there's a function called sort of recrawl. You recrawl with all the new data that has been added to the data set and only index those to add to the existing index.
And that's something I could have on a schedule as well, right? So I don't have to necessarily manually trigger that. I could say, I know my data is going to be changing every day. I want to reindex every night or something like that.
For sure. Yeah. You could use the API endpoints for like a specific timeline every week, every day, or whatever the schedule is. Or you could also set up a function that would say, do a crawl. And if there is any new data present, then crawl that and update the index.
Fantastic. So it sounds like there is lots of functionality already for being able to get the data in and being able to leverage this amazing powers.
Yeah.
Okay, so we saw some really cool demos. We learned a lot about how we can start leveraging images in cognitive search. Where can people go to learn more?
Yeah, so you could get started. The easiest ways to get started with the blog announcement post that we just saw, as well as Vision Studio, where you can try out these experiences and create an easy POC. Or you could go into the Python, the GitHub repo that we have, where you could use that code to set up the image retrieval systems for your search index.
Great. So I'm showing those links below. They're also in the description for this video, so you can go check those out and you can get started with the image search capabilities in Azure Cognitive Search. Thank you so much for hanging out with us today.
Okay, so now we have Varsha here live to answer your questions. Thank you for that amazing demo showing the power of image search with vectors. We do have a question, and I see a comment about how the power of being able to search your own images with this is really cool. That used to be kind of like a search engine feature. So here's a question. Oh, I hit the wrong one. Sorry about that. Here we go. Is there an easy way in Azure to expose this capability to non-technical users? A simple search bar for them to search images for using text?
Yeah, so definitely the demo that we saw in Vision Studio, that's an easy application to just do image search without like the heavy text embeddings that we saw with direct sessions on OpenAI Ada text embeddings. So that's the easiest way. There are samples online within the PR that we shared. So there is a RAG sample where an application and a UX is already built for text to image search as well. So that's an easy plug-in with the PR.
Great. And then, so are you talking about the AI Studio where you could upload images there and kind of play around with it? Is that meant to be used more for demo purposes, or is it meant to also be used as like as product, I guess?
Yeah, so that's specifically for demo purposes,
Okay,
but that's an example of how an easy application could be built.
I see.
But you could also use it for POC. We're seeing a lot of our customers use it for initial testing to understand if the base model is good enough or it needs any additional fine-tuning or customization on top of the base model, which is like a general purpose image search model. So that's an easy way, again, to get like a POC started.
Awesome. And then um, how would one maybe moderate or kind of talk about AI, responsibility and safety? How do you moderate the types of text and things that people are putting in for image searches?
Yeah, so I think that's a great question. Considering it's an open vocabulary search, it's not a fixed vocabulary like you would have in tags, right? Where you could say a specific tag, you can do a block list and make sure people searching for it either don't get results back or that particular tag doesn't or translate to something else. So moderation is much easier when it's like a finite vocabulary. With open vocabulary, we do have options like content moderation and content safety APIs, which is another part of Azure AI service that we offer. on text, you could do the text moderation does have the ability to also provide block list. So you can pick the severity level to which you want to moderate. The same can be done on images where you have different classes, and you could pick those classes, whether it's adult category or gory category, and figure out what you want to moderate your final images on, and use those APIs to moderate content on both text side and image side.
Great. So it sounds like it'll be super easy to add AI and content safety into these different features. Super important for when building out anything is to think about the responsible AI pieces of building these intelligent solutions. Let's see, do we have any other questions here? Someone said that the demo also makes them hungry. Legit, like I am hungry now, especially the noodles one. Oh my gosh, looked so good. I think that's all the questions we had there. Do you want to speak to at all the dimensions of the Florence embeddings?
Yeah, so right now the model versions that are out in public preview, the dimension is 1024 vector embedding space. So we're also having the same vector embedding space even for the multilingual model that I mentioned. So the 100 plus languages that we're coming out with soon would also have the same dimensionality.
Okay, great. And that just means more accuracy and more support to get better results, basically.
Yep.
Great. Well, we don't have any other questions here. I don't know if I have any others. I think actually one that was asked earlier that you could maybe speak to a little bit, even on this one, was around, let me see, where was it? Kind of the different use cases, I think, and how to get better results and things like that.
Yeah, so definitely fine tuning, and we recommend this to all our customers to try out with a small data set and make sure that the data that they're looking for works well, right? What I mean by that is we've had instances where people specifically look for jargons in some terms. So it could be manufacturing. They're looking for very specific like faults and what those terms are. And that's not what the model is trained on, considering it's like this open vocabulary world sort of search scenario. So it won't work well for those kinds of very specified tasks. So we would definitely recommend take a data, use it for the POC, do the testing on it. And then you have fine-tuning capabilities with custom vision service that we offer within vision space as well. So that's another way to understand how to fine-tune the model and what to expect out of the model embedding. So yeah, testing, fine-tuning, those are core basics of AI model deployment.
Right. So we're leveraging these pre-built services, but we're still applying those AI engineering kind of like tasks of making sure it's working and sometimes needing to customize it to our jargon, our industry, our different tasks that we need. So that power is there. So they're able to do that. And it just gives you like this great baseline to start in, right? And then you can, and rather than starting from zero, and then you can really fine tune it and get to what you need and get probably a really good result much faster by leveraging those tools. Okay, well, I don't think we have any other questions. Oh, wait, maybe we do. Here is one. Can you explain what you mean by hybrid search and in what scenarios does it help?
Yeah, great question, Evan. So with pure vector search, as we saw, you do get results from the images and the contents in images itself. So you can think of like you have nature and you have like sky, like kids playing volleyball, whatever, right? So it's the contents within the image that you sort of search for. When I think about hybrid vector search, this is like a combination of the keyword-based search that we were talking about, which is how the traditional image search pipelines were built. So even like metadata aspects, like I'm searching for PCs on one of the retailing websites, right? Mm-hmm. And if I want a specific PC of like a specific model version or like a Windows version, I would then type those aspects out, which are not present in the image itself, but it could be associated as metadata. So it could be in the product aspect of it, or I'm searching for clothes, and most of these clothes have like product IDs or reference ID of that particular product. So those are aspects that you connect on to the image. So you have these pipelines of raw image indexing as well, metadata indexing. So hybrid combines the goodness of both, and you can find for something as specific as product ID, but also use the semantic search, which is like this open vocabulary search with vector search.
Great. Yeah. And we talked a little about that with Liam as well, around using those different keyword static words along with the embedding or filtering down to different categories, like you were saying, to get a good result and be able to get the right result, right? So with that, I think we're out of time. I want to share this comment though, because this is so cool. Like all of the things that we've talked about today are so cool and are just cutting edge. And I don't even think we've like really scratched the surface to see how many things people are going to be able to build and accomplish with these types of tools. So thank you so much, Varsha, for coming and answering questions and doing this amazing demo.
Yeah, thanks for having me, Kelsey.
And I will say goodbye to everyone else. Thank you for hanging out with us today. Again, we went over like a lot of really cool things. We put some links in the chat. Go try it out for yourself and have a good rest of your day. Thanks.